All right, so like I said, chapter 7 is going to be all about exponential functions. We're going to just kind of focus on the graphs today. This is what the general form of an exponential function will look like. We'll eventually, when we'll look at some like kind of word problems, we'll talk about what different parts of this can represent. There's really 3 parts in this formula that we're really focused on: the A, the B, and the K. The X and the H, not so much when we're graphing. So one thing in this formula, your K tells you where your horizontal asymptote will be. You probably haven't heard of this word asymptote before. Maybe you have, maybe you haven't. But an asymptote, basically, it's going to be represented by a dashed or a dotted line, but basically it's a line where your function approaches but never crosses. So it's like it's a line where what you're graphing gets closer and closer to, but it won't ever actually cross. One thing to keep in mind, your asymptote is not actually part of your function, but it's helpful to draw it in when you're graphing by hand. So for example, some of these functions, like for these functions, if you graph them in delta math, you're not going to see the asymptote. They're not going to draw that in. They're just going to draw the actual function. So keep in mind, in this formula, K, though, is how you get your asymptote. So if you have +3, your horizontal asymptote is going to be at y equals 3. Since it's horizontal, just keep in mind all of our asymptotes today are going to be y equals a number, because that makes a horizontal line. Like y equals 5 is a horizontal line. So all of our asymptotes will be y equals something. The B is important because in your B is the number that's being raised to a power. If your B is greater than 1, like it's like basically like 2, 3, 1.5, 3.5, you're going to have exponential growth. So this is called exponential growth if your function gets bigger as it goes left to right. So that's why this is called growth. One thing to notice, I know it might be kind of hard to see with like the picture, it's a little bit blurry, but if you look, we really have an asymptote. Let me see if I can draw this better. But there's really an asymptote at y equals 1. Like, and so that's what it would look like when you draw it in. But basically, it's probably hard to see. Maybe if I can show you a better picture, but you're going to see that this function, it gets closer and closer to that line y equals 1. Like if you looked at like a point here, you might have like -6, 1.1, and then it might be like 1.01, but it's never going to get equal to 0, or sorry, equal to 1 for its y value. Like it's just going to get closer and closer to this line. And honestly, it looks like it touches, but if you zoom in, you'll see it's still slightly above the asymptote. So it won't ever touch, or it will never cross this asymptote. And because this is your K value. So since your K is 1, you have that asymptote. Since this is a +2, that's why it's growth. It's bigger than 1. And on the contrary, if you have a B value that's like a fraction between 0 and 1, you're going to have a graph that is, it's called exponential decay, because your graph gets smaller as it goes left to right. And since your K value is still 1, you're still going to see you have an asymptote at 1. Like, I know it's kind of hard to see with the scale on this, but basically your graph's going to get closer and closer to that asymptote, but never cross. Like, you will never have a y value that's equal to 1 or smaller than 1. Like, it's just going to get closer and closer. And it looks like it almost turns into like a straight line, but it's actually going to, it's so slight, but it's getting really small. Like, you might have like a y value that's like 1.01, 1.00. Like, it's going to get closer and closer to 1, but never cross. So if your B values are like greater than 1, you get exponential growth. If you have a K value that's, or sorry, if you have a B value that's a fraction between 0 and 1, it's going to be decay. But do be really careful. If you remember from the general formula, that you can have a coefficient in front, your A. If you have a negative A value, remember a negative in front for most functions we've seen that reflects it, you can have your graph be reflected. So for all of these graphs, I made them have the same horizontal asymptote, like they're all going to have a K value of 1. But be careful if your graph reflects, like it will kind of change what I said above about the b values. So because this is really like a negative and then times the 2. So this is actually decay. And this one, if you look, it's actually growth. So if you have like a reflection, first off, it flips it on the other side of your asymptote, and it changes what I just said in like the second rule. So if you have a negative in front, it actually does the reverse, like a negative whole number b value, like a number bigger than 1 is actually decay, and a negative fraction actually turns into growth because it reflects, so it kind of changes what you have. So, and just keep in mind, this is not anything you have to memorize. Like, I don't expect you to know off, like, I wouldn't ask you, like, oh, we have a negative, what is this going to be necessarily? But it is helpful. I think a lot of what I'm showing you right now, you'll kind of naturally start seeing after graphing a few of these. But it's not anything I'm going to require you to memorize. I don't think so, at least. I mean, let me know if you, we'll kind of see when we do these questions today. But it is helpful to kind of have an idea of some of these properties because that might let you kind of know what your graph's going to look like before you even graph it. All right, so that's kind of it for our notes. I just wanted to do some examples. You're going to have 2 types of problems in your Delta math today. You're going to have your first sections, they're going to just ask you to graph your exponential function. So the first thing you always want to start with, and there's going to be a drop down menu where you have to click what type of asymptote. For all of your problems, you're always going to have a horizontal asymptote. But remember, your k value tells you your horizontal asymptote. So our asymptote, and they're always going to be horizontal. I'm just going to abbreviate asymptote like this because I write too big. But our horizontal asymptote is going to be y equals 5. So in Delta Math, you kind of click and drag a dotted line, but it's just going to, like our horizontal asymptote would be at y equals 5. So this horizontal line here. Okay, and they ask us to get a couple points. So this is where I'm going to show you 2 ways. One way is to do it like completely kind of like if you didn't have a nice calculator, and then I'm going to show you how you can use your graphing calculator if you'd like. But basically, you want to think of 2 numbers that are easy to plug into this. So one piece of advice, if you remember, x up to 0 is 1. So if we can make our exponent equal to 0, that's always an easy one to work out. So for, oops, I meant to erase. So for this one, I would choose to plug in -6 for my x, and then 1's also an easy power. I mean, you could pick any x values you want as long as you get whole numbers, because Delta Math's a little bit picky. But if you, for example, if you plug, let's just plug one at a time. If you plug in -6 for x, you're going to have -3, 2, -6 plus 6 would be 0. And that's why I picked -6, because it's always nice if you can get a 0 exponent. It simplifies. So this would just be -3 times 1 plus 5. So -3 plus 5 would be -2. So one of my points I would have is -6, -2. And then we need one more point. You need at least 2 points. I'm going to choose to plug in -5, because if you get a power of 1, that's also an easy one to plug in. But so if you plug in -5, you would have 2 up to the first power, because -5 plus 6 would be 1. So then if you simplify this, well, that would just be -3 times 2. That would be -6 plus 5, or that would just be -1. So your graph's gonna, let me just make sure I didn't screw this up, did I? I should have, I didn't get a chance to finish my key before class. Let me just make sure. So -6, so it would be -3 plus 5. Oh, sorry, this should have been +2. -3 plus 5 is not -2, it is +2. So let me replot these points. So it was looking, because I did start graphing this one. I was like, that's not what I got earlier. So sorry, we should have had -6, +2. So my mistake there. But this next one is fine. -5, -1 is correct. So if you graph this, it's going to kind of go down, but it's going to get close as it goes this way. It's just going to get closer and closer to that asymptote. And here's like if you so that's how you could do it. One way you could kind of strategically pick 2 points, but you could also, if you'd like, what they're going to show you in Delta Math is they're basically going to tell you just use your graphing calculator. So if you still have that graphing calculator app on your phone or whatever or if you have an actual graphing calculator, you could just graph this equation. So if you remember, this was -3. Oops, let me clear that. Sorry. Oops. So -3 parentheses 2. When you put it in though, you want to put parentheses for the like your exponent part. So it'd be x plus 6 and then plus 5. You really got to make sure you put these parentheses when you have like a more than one thing like in the power. So if we graph this, you'll see one, it kind of does make the shape we just sketched, but you could do second graph to kind of use your table to get some points. Like if you see right there, there's -6, 2 and -5, -1, but you could use any 2 points as long as you can kind of see the shape. And if you need more than 2 points, Delta Math is just going to have you do 2 points and it's going to sketch it for you. But if you're actually doing it like completely by hand, you can use more than 2 points, obviously, like that helps. But you're welcome to use your graphing calculator as well to help you get your 2 points. Okay, let's look at another one of these. I wanted to look at one where you have a fraction, just to kind of talk about if you're not using your graphing calculator. So first off, notice there's nothing added on the outside. We don't really have a k value. So if there's nothing added after your parentheses, you really have a horizontal asymptote of 0. Because there's really no k value. Here, let me not be so sloppy. And then you just want to get 2 points. So like I said, it's always easy if you can get, well, here's the thing with Delta Math that gets a little bit tricky. And this might be why you want to use your graphing calculator. They only want whole number coordinates. So the only way, so one way, I mean, obviously we can make this equal to 0. So if I did x equals -2, I mean, that would just be -1/3 up to the 0 power, which would just be really -1. Because you'd have -1/3 up to the 0 power is just 1. So like one of my points would be -2, -1. But I don't want to plug in 0 or I don't want to plug in 1 because I don't want to get a 1/3 up to a whole number. Because if you take a fraction up to a power, like a positive power, it's going to stay a fraction. The only way to change a fraction into a whole number is to have a negative power because that'll do a reciprocal. That'll flip it. So for example, if I made my x equal to -1, if I plug that in, I'd have -1/3 up to, oh, not -1. Let's do -3, my bad. Like if you did -3, -3 plus 2 would be -1. Remember, a negative exponent flips your fraction. So this would actually be really just -3. So we'd have -3, -3. And then if you can kind of see, I mean, your graph's going to get closer and closer to that asymptote, then it's going to kind of go almost straight down. Like it's going to get really small really fast. But like I said, you can also use your graphing calculator to get some points. So if you type in what our function is, it's -(1 divided by 3) up to, and just like I said, when you put the power, make sure you put parentheses. If you don't put parentheses, you're probably going to get it wrong. Like it's probably going to graph it wrong. But you can see this does, well, first off, when I graph it, I can see, does that look like what I just got? You could use that to check. But if you do second graph, you could get your whole number points. Like there's -3, -3, -2, -1, -4, -9. So Delta Math is going to tell you to use a graphing calculator if you look at like their examples or their help video. But I don't care. I'm just showing you how you would do it if you didn't have a graphing calculator. You'd want to kind of strategically pick points that work out nicely. But that's how your graphing section is going to work. Get your asymptote, then either use your graphing calculator or plug in a couple points yourself. So that's what your first section is going to look like. Any questions so far? I haven't been looking in the Zoom chat. Okay, nothing in there. But anyone in here have any questions either so far? Okay, the next section on your Delta Math is going to be, it's a little bit, it's called features of exponential functions. If you look, like this is copied and paste. you're going to see there's a lot of options. What I have in the notes here, though, these options that I picked will never change. So when you're doing your problems in Delta Math, like look at this example because you're going to pick all of these options I already have filled out here. These will never change, okay? But to think about what these other options, let's kind of look at this problem together. So this says the function f of x is an exponential function with a horizontal asymptote of y equals. So that will be the same for all the problems you look at. I think I only put 2 of these, if I remember right. But if you look at our asymptote, look where it gets really close to. It gets really close to -4. So that would just be y equals -4. If you look, that's where the asymptote is. That's where it's really getting close to. And so then they ask for the range. Remember, range is all your y values. So if you look at our range, and it's going to be a drop down, so I believe you have some choices if I remember right. But if you look, our range is everything above here. Remember, it's never going to cross at -4. So it's going to use an inequality, but it's going to be everything greater than -4. And wouldn't be equal to -4 because it never touches, but and it is, for this one, it asks, I believe, if it's increasing or decreasing. So this graph is increasing because it gets bigger as it goes left to right. And then they ask for the domain. I can't remember what the option, it's a drop down, but your domain is all your x values. It would basically be all real numbers. I can't remember how it rates it. I don't know if there's an option with all real numbers. It might be from -infinity to infinity. It might be a double inequality. I'd have to check what they put. It might be even something like this. Wait, what would it look like? I'm trying to think. How would you write that as in double inequality? I'm kind of going blank. It might look like this. Wait, no, it wouldn't be like. I'll have to see what their option is. I can't remember, but it's a drop down. But basically, you would, the domain is all numbers because it's going to go for the left and to the right forever. And then it asks for your end behavior. So as your x goes to the left, what are your y values doing? Well, your y value is approaching 4 when it goes to the left. Like it's getting closer and closer to this asymptote as it goes to the left. As your graph goes to the right, your graph is approaching positive infinity. Like your graph's getting bigger. So you'll have a couple questions where you kind of have to fill these in, but look at this example in our notes because like I said, the ones that I have like already filled out will be the same for each question you look at. I can't make it, so it already fills those out for you. So that's all I have in terms of our notes today. If you want, I could do like an extra problem in the Delta